Good evening. Good evening, everyone. Good evening. My name is John Adjunct, and I am a student project manager at the Clark Forum for Contemporary Issues. On behalf of the Clark Forum, the Office of the Senior Associate Provost, the Career Center, Pre-Health Society, the Pre-Health Program, Division of Student Life, the Wellness Center, the Department of Biology, and the Program in Policy Studies, I would like to welcome you to tonight's event, Reducing the Global Burden of Dementia, the First Alzheimer's Survivors. Clark Forum's student project managers, including myself, initiated this event. Today is April 25th, 2018, and I would like to provide you with a list of things we have accomplished to date in the field of health. We have mapped the human genome, successfully cut out the HIV gene in mice using CRISPR technology, developed highly effective treatments for hepatitis C, and have made breakthroughs in treatments for many forms of cancer. Today is April 25th, 2018, and I would like to provide you a brief list of the progress we've made in Alzheimer's research. In 2003, the FDA approved memantine as a drug for Alzheimer's treatment. Essentially, memantine functions to protect against neuronal exocyticity, which is the process in which nerve cells are damaged or destroyed by extreme amounts of stimulation from neurotransmitters. Since then, no truly new drugs have come to the forefront, and all those currently in circulation have proven to be abysmally ineffective in the long run. Perhaps that's what scares us most about the third leading cause of death in the United States. We have no semblance of a cure, and we truly don't have a firm grasp on why the disease occurs. Over the past few years, I've thought about memory a lot, perhaps every day. I think often of how so much of our lives, our relationships, our existence relies upon our ability to recall and actively engage with that information. Our active remembrance is what makes us who we are. Someone very dear to me and my family has been living with Alzheimer's, and I've watched, spoken, grown, cried, and existed alongside her in the passage of these long years. While I will gladly give the zenith of my youth to ensure her comfort, the only heartening retribution towards the disease that I will accept for all the time that it has stolen away from us will come in the form of a cure. The thing is, you can't really explain the impact of the disease if you're not living with it or alongside someone who is day in and day out. Even as I was writing this, I struggled to both articulate and to honor a portion of the narrative of a woman who has done more for me than I will ever be able to do for her. But I speak this not in defeat, but as a prisoner of hope that one day the diagnosis of Alzheimer's will be merely a dark stain in the remembrance of our history. I am pleased to introduce tonight's speaker who will discuss the new approaches that he and his team have taken to treat Alzheimer's and the 3 subtypes of the disease they have identified. Dr. Dale Bredesen is director of the Easton Center for Alzheimer's Disease Research at the University of California, Los Angeles, and founding president and CEO of the Buck Institute for Research in Aging. Bredesen is the past director of the program on aging at the Burnham Institute and has held faculty positions at University of California, San Francisco, Los Angeles, and San Diego campuses. He has also served as the chief resident in neurology and as a National Institutes of Health postdoctoral fellow at University of California, San Francisco. Through his establishment of the Alzheimer's Drug Development Network in 2008, alongside Dr. Varghese John, they have been able to identify a myriad of new classes of therapeutics for Alzheimer's disease. Bredesen is the recipient of several grants from the Buck Institute for Age Research, including the National Institutes of Health Eureka Grant for Exceptional Unconventional Research Enabling Knowledge Acceleration, and the California STEM Agency's SEED Grant for Scientific Excellence through Exploration and Development. Bredesen's most recent publication, The End of Alzheimer's, the first program to prevent and reverse cognitive decline, is a New York Times and Wall Street Journal bestseller. In the book, he identifies 36 metabolic factors that contribute to the various progressions of Alzheimer's and offers a personalized program which lays out how these factors can be reestablished to enhance cognition and to reverse cognitive decline. There will be a question and answer section immediately following the program, so please hold all questions until that time. The Clark Forum welcomes differences of opinion expressed politely, thoughtfully, and succinctly. Disruptive behavior or harassment of the speaker, members of the Dickinson community, or audience members will not be tolerated. At this time, I ask that you please silence all cell phones and other electronic devices. In the event of an emergency, please know that the handicapped accessible exits are located on the west side of the building. A book signing will take place at the conclusion of the presentation. And now, please join me in welcoming Dr. Dale Bredesen.
All right, can everybody hear me okay? Great. Thank you, John. Thank you, Dr. Farrell, for the invitation. Thank you to the Clark family and the Clark Forum for this wonderful program. And thank you to the faculty and students of Dickinson College for having me here today. And thank you to the people from the community who are attending. And shout out to everyone who's live streaming. So thanks everyone for being here. And I want to ask you to do something different tonight, which is to forget what you've heard about Alzheimer's disease, because we hear about things all the time. And I want to show you a very, very different look and a very, very different approach to this very difficult problem that we've had to deal with. So I want to talk tonight about reducing the global burden of dementia. This is a $1 trillion global problem that is on the rise, that is set to bankrupt Medicare in the upcoming years. So major problem. Now, when I think of a liberal arts college, I have to say I haven't been to many liberal arts colleges. I didn't go to one. I went to a technical school. My wife went to a large university. Our two daughters, Tess and Tara, went to large universities. And so I haven't had a lot of exposure. So I actually thought this was an interesting opportunity. So of course, when I think of this sort of thing, of course, I think of Faber Academy, right? That's the obvious one to think about. And in fact, my friend and colleague, Tom Mount, was centrally involved in making Animal House, making the movie, and so has really great stories about the making of this movie. But you know, if you look at the larger universities, for example, as you probably know, Einstein was censured at one of his universities for being very outspoken about his causes. Linus Pauling, for his pacifism and nuclear disarmament writings, was heavily criticized prior to winning the Nobel Peace Prize for his work for nuclear disarmament. So universities don't have a great track record sometimes of honoring new and creative ideas. And it's exactly a place like Dickinson College that fosters new creative thinking, innovative ideas. And so my hope is that some of the students here tonight will be involved in the very things that we need to change our healthcare system. And as I'll show you tonight, we are in real need of some significant change in a system that has not been successful for us, as you know. And in fact, in the area of neurodegenerative disease, one could argue that this has been the area of greatest biomedical failure. If you have Lou Gehrig's disease, if you have Parkinson's disease, if you have frontotemporal dementia, Alzheimer's disease, corticobasal degeneration, you just go right down the list, PSP, on and on and on, then there's not a lot of hope. And we want to change that. So I hope that some of the students who are here tonight will be centrally involved in doing just that. So this evening, what I want to show you has tremendous implications for everyone here. This is a story about Aesculapius and Turing. It's a story about medicine, and it's a story about computation. It's a story about tradition and permission, how medicine has been operating, often to its own detriment and the detriment of us as a society with respect to our health. And a story of that versus precision and remission, which is the direction we need to go. It's a story about hopelessness, and it's a story about joy. It's a story about people who are disruptors. We hear this a lot with Silicon Valley. We almost never hear it when it comes to our healthcare system. Disruptors and jobs worths. It's a story about collective, obdurate blindness and what we can all do together to overcome that. So, lots of numbers, and unfortunately, all the numbers, as bad as they are, underestimate the problem. This is a major, major issue. The people here, approximately 25 of us will die from Alzheimer's disease, of the people who are here tonight, unless we do something very significant for prevention and reversal. As John mentioned, it is now the third leading cause of death in the United States. And in the UK, dementia is now the #1 leading cause of death. It's actually exceeded both cancer and cardiovascular disease. So this is a major problem. And of course, it doesn't just affect the individual, it affects the families, it affects their interactors, and pretty much everybody knows someone who has Alzheimer's disease or has some form of cognitive decline. So it touches us all in one way or another. And back in 2011, President Obama signed into law the National Alzheimer's Project Act, so-called NAPA, and we actually had our first meeting in 2012, and people sat around and said, okay, what are we going to do about this? And so there now is a national plan. The problem is the national plan doesn't tell you how to fix it. It doesn't tell you how to prevent it. It doesn't tell you how to reverse it. It just says there's something we should do about this. And President Obama, as you know, said he'd like to see something that's 25% better than what we currently have by 2025. Well, for people who are already suffering cognitive decline, that is a long time to wait. And of course, 25% better than something that really doesn't work is not all that good anyway. So we want to make this something that is much more effective and happens much sooner. If we don't do something, you go out here to 2050, and we're having major, major problems. This is going to be a huge global problem. And as I said earlier, among many other problems, it will completely bankrupt our Medicare system. So this is a huge and growing issue. And as you probably know, and as Maria Shriver has pointed out, women are at the epicenter of this epidemic. You, if you are a woman, you represent about 2/3 of the cases and about 60% of the caregivers. So this is a huge problem. And in fact, as of today, if you are a woman, your chance of developing Alzheimer's is now higher, is now greater than your chance of developing breast cancer during your life. So a huge and growing problem. And as you know, when you go in and you say to the doctor, well, what are you going to do for me? They say, there's not much I can do. I can give you a prescription for something that doesn't work very well, and that's really it. You're going to have to live with that. There hasn't been a cure. And we keep hearing again and again and again, hopefully we'll have a cure from a drug in 10 years. Now, of course, we heard that 10 years ago, 20 years ago, 30 years ago, and we're still hearing that today. So we may have to do something different. We may have to look at this disease and consider it in a very different way. And many people have heard these quotes, there is nothing that will prevent, reverse, or slow the progress of Alzheimer's disease, and everyone knows someone who's a cancer survivor, no one knows an Alzheimer's survivor. So let me show you some of the first tonight. Now, if you go into your doctor today and say, I'm having trouble with my cognition and Alzheimer's runs in my family, and I really would like to have you look at this, what you'll find is that there is a very, very sad state of affairs. First of all, as you probably know, people often wait until very late. So when we hear from someone that someone is announcing that they have Alzheimer's, they've had the underlying problem for many years, and they've often had symptoms for many years as well. And of course, you have the underlying pathophysiology for a decade or two before you even have a diagnosis of Alzheimer's. And then you go through stages of so-called SCI, subjective cognitive impairment, where you know there's something wrong, and your spouse knows there's something wrong, and your coworkers may know, but you're still testing within the normal range. That's SCI. Then that can last a decade. And then you go on typically to MCI, mild cognitive impairment. Now, not only do you know that there's something wrong, but in fact the tests are showing it as well. You're not able to do the things that you were able to do before. And then that typically lasts a few years, and then you typically go on to full-blown Alzheimer's disease. And by definition, that means that you've now had difficulty with activities of daily living as well. So we want people to come in, the earlier the better. We want them as soon as there's any change, and preferably for prevention when they're asymptomatic. So we recommend that anybody who's 45 or older get checked out, get on prevention. Let's end it with this generation. So you come in late, and what happens? People wait. They wait a long time. They know that there's a stigma attached to the diagnosis, so they just don't want to go in. That automatically makes it more difficult. They finally do go into the primary care provider, and what does he or she do? Say, well, I don't need to send you to a neurologist. I mean, I can write a prescription for Aricept or memantine, as we heard, just as well as anybody else. Why do I want to do anything more than that? And so people often don't get specialty care. And then finally, they're sent to the specialist very late. And what does the specialist say? Well, I can't help you. I'm going to make sure you can't drive. I'm going to take away your driver's license. I'm going to write down memory problems in the chart, which means you cannot get long-term care insurance, so take that away from you. And although I can't help you, would you mind coming back every 6 months for a spinal tap so I can renew my grant? That is how bad things are today. So we need to change that. And so here's an example. This is from one of the leading centers. There are typically 3 centers in the US that are held up as the gold standard, the best places, the best of the best of the best. So here's an example of a real person who fairly recently was seen at one of the greatest centers in the United States. And here's what the doctor wrote. And this doctor is an expert in this area. So MRI of the brain and blood for complete blood count, metabolic panel, thyroids, B12. I asked the patient and his wife to keep an eye on his disabilities, to manage money, medications, and transportation. I prescribed donepezil, that's the Aricept, 5 milligrams once per day. Okay, so this is the gold standard. What did this person not do? There was nothing about the genetics, nothing asking, do you have the major gene that's associated with Alzheimer's? Is this something you should be talking to your children about? Do we need to look at them? Nothing mentioned about that. Many genes that are associated, not just ApoE. Nothing about the inflammatory status, even though there are more and more data that this is a critical component to whether or not you're going to develop cognitive decline. So nothing was checked about this, not hsCRP or interleukin-6 or anything about inflammation. Nothing about homocysteine, even though tremendous amount of information. This is related to your body's ability to methylate and also related to its ability to detoxify. This wasn't even checked. Nothing on fasting insulin. This is turning out to be an important contributor to cognitive decline. Wasn't mentioned, wasn't checked. Nothing on hormonal status, even though in fact a number of hormones are very important in supporting brain function. Nothing on toxin status, even though it's turning out that specific toxins play an important role in whether or not you're going to have Alzheimer's disease. Nothing about the innate immune system. That's the ancient part of the immune system that is activated in Alzheimer's disease. And in fact, part of the stuff that you make in your brain when you have Alzheimer's disease is part of the activation of this ancient part of the immune system. This wasn't mentioned, it wasn't checked. Nothing on gut health. Everybody's heard now the importance of gut health and its relationship to brain function. This wasn't mentioned, it wasn't checked, nothing. Nothing on the microbiome, such a critical piece for Parkinson's, for Alzheimer's, for depression, for other things. Nothing on the blood-brain barrier status. Nothing on MRI volumetrics. So there was nothing about, well, let's see what is the percentile of volume for your hippocampus. If it's low, your prognosis is worse. If it's higher, your prognosis tends to be better. Nothing about that. So this is the best of the best of the best we have to offer. And this is what's been left out of this evaluation. Then the person prescribed a drug without knowing whether the patient actually had Alzheimer's. And then interestingly, nothing was even mentioned. This person was about 50 pounds overweight, had a high BMI, which should be 20 to 25. This person was 33. This wasn't even mentioned in the chart. The feeling was apparently that the brain is separated from the rest of the body. And of course, study after study after study shows that's simply not the case. This is a whole organism we're dealing with. So no plans to address that. And then this person also had pre-diabetes, which is a key risk factor for cognitive decline and Alzheimer's disease. Wasn't mentioned, there was no plan to address this, none of this. So we need to do better. Here it just shows the last few years, various drug trials, and there are, I call this Game of Thrones because 244 trials in one decade, 243 failed outright, and you heard earlier about the one that succeeded in 2003. That's been the last drug approved. So this is a major, major problem. And in fact, if you look here, for example, semaglutide, the one in the top in the middle there were over $500 million were spent developing this drug. Not only did it not make the disease better, it actually made it worse. So it was worse than nothing, worse than water. So there's something wrong when we have the best and the brightest developing things to help this disease that are actually making it worse. So the question is, are we really, with the direction we've been going, Are we really breaking through to a cure for Alzheimer's disease? And if not, how are we going to go about figuring out what we need to do to have a positive result? What are we going to do about this illness? And as I said earlier, this really has implications for other neurodegenerative conditions as well, and ultimately for all complex chronic illnesses. These are the ones that are killing all of us today. 100 years ago, we were dying of simple, typically infectious illnesses. And of course, the great success of 20th century medicine was to combine public health changes and specific antibiotics to make it so that, in fact, very few of us die. Now, yes, we may get pneumonia at the end stage when we have something else, but that's not the thing that is in the long term killing us. So now almost all of us are dying of very different illnesses, complex chronic illnesses such as cancer, such as cardiovascular disease, Alzheimer's, Parkinson's, type 2 diabetes, these sorts of things, very different. So let's look now at a very different approach and ask, what can we do about this illness? So when I was in college, I read a wonderful book called Machinery of the Brain and learned about how the brain works and how it's like a computer and how it's not like a computer. And one of the things that really struck me about being in college is that I saw people around me and they were solving insoluble problems, problems that seemed to be impossible to solve. They were saying, how can we actually do this? And so this is what we want to do. We want to change our frame of reference until what we see as Alzheimer's disease actually tells us something about what it really is. When we can get a grip on what is this disease, and it tells us, here's what you do to prevent it, and here's what you do to reverse it. So that's what we want to do. We want to take a different look at this. And I want to show you first some of the outcomes, and then I want to go back and talk to you about how do we get those outcomes, and then what do we need to do in the future. So here's an example. Here's a woman, and I talked a little bit about her in the book. This is one whose mother died with dementia, started when she was 62. This woman was unable to navigate on the freeway. She started her symptoms when she was about 65, so a little bit older than her mother, but not much. Very similar. She had been through it with her mother. She had seen years as her mother went into the nursing home. It was very depressing to her. She was unable to navigate, and very similar symptoms to many people. Couldn't remember what she had read. She worked for the government. She would read to the bottom of the page and then have to go to the top of the page again. And so she was unable to prepare the reports that she was supposed to be preparing for the government. And so she was actually going to have to leave her job. She couldn't remember even 4-digit numbers. She went into her doctor, actually, and the doctor wrote down memory problems. And so then when she went to try to get long-term care insurance, she could not get it because of what had been written in the chart. She had a retinal scan which actually showed amyloid, and actually greater than the control positive. So she had a significant amount. So she is a typical person with early Alzheimer's. And so I got a call, and this was back now in 2012, and we had actually just been turned down. In 2011, we proposed the first comprehensive protocol to treat people who had pre-Alzheimer's disease, so-called MCI. And this was to be done in Australia with and without a new drug that we had discovered in the lab. And what we were told is, we're not going to let you do this because you're asking to change more than one thing at once. And they said, obviously, you guys must not know how to do clinical trials because you're asking to change more than one variable. And we said, well, you guys must not understand Alzheimer's disease because you don't get it from one thing. For pretty much everybody, there are multiple contributors, and you need to address those contributors. So we got turned down. We got a very nasty email from a philanthropist who had supported some of our work and said, if you were working for me, I would fire you. You know, how could you let this happen? On and on and on. So I was very depressed then. And shortly after, I got a call from a friend of this patient. And this patient lives on the East Coast, but her friend happened to live in San Francisco. And this person called her friend and said, I'm going to commit suicide because I know what I have. It's the same thing my mother had, and I'm going to die from this. And I watched her and go downhill, and I'm not going to let that happen to me. So when I got the call, she said, well, would you see this person? I said, I haven't seen a patient in 20 years. You know, we have a lab. I've said the best I can do is I can talk to her about what we were trying to do in that trial, but I don't have anything to offer her. I can give her a list of things and she can take it back to her doctor if she wants to talk to him about it. So the woman actually did fly out. We spent 2.5 hours going over the whole theory. All this was long before we'd published any papers on this or anything. And so we went through everything, and then I thought, you know, I'm never going to see this person again, and I hope she does okay. So 3 months later, at home on a Saturday, I got a phone call. I picked up the phone, and this woman said, I can't believe it. She said, I'm back to work full time. I'm doing great. She said, my memory is better than it's been in 30 years. And so I hung up the phone, and I looked at my wife, who's an integrative physician, who told me 20 years ago that whatever we found in the lab was going to have something to do with some basic things like diet and exercise. And of course I said to her, no, we're going to find one molecule. It's going to be one specific thing, you know, one region. Of course I should have listened to my wife, you know, 20 years before. So anyway, I got the call, and I hung up the phone, and I looked at her, and I said, wait a minute. This is working. This is exactly what we were trying to do in Australia with the trial that we were not allowed to do. So the woman then came back, and I said, do you mind if I take a video of you talking about what happened to you? And she said, that's fine as long as you don't use my name. So you'll see her in this video, and she talks a little bit about what happened with her.
So tell me a little bit about how things were a year ago.
Well, a year ago, I was having a lot of difficulty. I was very frustrated because my memory was poor. I had issues of being spatially disoriented, particularly when I was driving. I would get off the freeway at the wrong exit or not know where I was getting back on familiar routes. I would reach in my house for a light switch. I'd reach on the wrong wall, even though I'd always had the light switch has always been on the right side. I'd start reaching to the left. I'd call my animals a different name, my pets, and I was really worried about it. I was very stressed about it. So it was a very stressful time.
And how are things at work?
I have a job that requires a lot of mental analysis, a lot of thinking. I do a lot of research. I have to collect data, and design the study, and then do the analysis and write a report, usually under pressure. And I was finding that I just couldn't complete an assignment. I couldn't think about the analysis. It was just a jumble to me, and I would start procrastinating and putting it off, and the longer I put it off, the more stress I felt. So I was worried that I was not going to be able to continue with my career.
And tell me a little bit about how things are now.
Things are much improved now. My memory is much better. In fact, I would even go so far as to say I don't think that I have a problem with memory now, which is a great surprise to me from where I was a year ago. My thinking, cognitive ability, ability to do work, ability to do reports, I am back into the stream of things, being productive and being able to do my analysis and writing, which is fantastic.
And how's the driving?
Driving, no problem. I drive at night, I drive in the daytime. I know where to get off, where to get on. I'm on the highway, so I feel like that's a problem. I'm not reaching for the wrong side of the room for the light switch. I'm not calling my pets the wrong name, which I think they're probably grateful for.
And how overall are you feeling?
I feel great. I feel really, really good. I feel energetic. I feel more peaceful and calm about my life, but at the same time very enthusiastic. I've even started writing my book.
Fantastic.
A couple of chapters.
Okay, thank you very much.
So as you can see, her face was pixelated because she's back at work. She does not want people to know that she's been doing this sort of thing. This is still obviously a big stigma in our society. And in fact, if you call up tomorrow and say, you know, I'm going to take a United flight or an American flight somewhere, and someone says, don't worry, the pilot's been treated for Alzheimer's, everything's fine, many people would say, you know what, I'm going to call a different airline. So this is still an issue. We're not used to seeing, hey, here's a person who's doing really well, but they did have Alzheimer's. So here's another person I wanted to show you, and this is a very typical story. So he has the most common genetic risk factor for Alzheimer's, and we'll talk a little bit more about ApoE4 in just a few minutes. He had a single copy. If you have 0 copies, your chance during your lifetime to get Alzheimer's is about 9% or so. If you have a single copy, it's about 30%, and that's 75 million Americans who have that. So we'd like to prevent all of them from getting Alzheimer's disease. If you have 2 copies, and that is 7 million Americans, your chance is over 50%. So most likely you will develop Alzheimer's during your lifetime. So again, we want to prevent everyone from getting this. He had problems and initially couldn't remember his lock combination. That was the first thing that he noticed. And so he had a PET scan, and unfortunately it showed that he already had Alzheimer's disease. There's a change, it kind of looks like two L's. The temporal lobe and the parietal lobe has decreased utilization of glucose, and he showed that signature. So he was already in the early phases. Now he then went and had neuropsych testing, quantitative, multi-hour neuropsychological testing, 2003, 7, and 13, and you could just, he literally just documented his own decline. And by 2013, he was really not doing very well. And in fact, his doctor who did this study was saying, you know, you got to get your affairs in order. He had two offices, one on the East Coast, one on the West Coast, said you got to close everything down. As many people do, what he was doing is hiring extra help. So he would just focus on what was in front of him, and they would say, okay, don't forget to go here, don't forget to go there. And so by 2013, he was doing very poorly. And in fact, his scores here gone from the 84th percentile for the California Verbal Learning Test, which is a common one that's checked and is abnormal in Alzheimer's disease. He's down to the 3rd percentile. So it really fallen off a lot. Unable to remember lock combination, faces, schedule, and so forth and so on. And so difficulty at work. And one of the interesting things about this guy is that during his entire adult life, he had been a whiz with adding numbers. So his accountants would show him, okay, here's a column of numbers, and he would go, oh yeah, that's about 430,000. And they're like, wow, that's really quick. Well, he lost that ability to add numbers quickly in his head with his Alzheimer's. He got it back on this program and still has it to this day. And so he came in at the end of 2013, so he's now been on this for almost 4.5 years. And interestingly, so as many of these people do, it takes 3 to 6 months to see, you got to identify all the problems, get on all the right things, and then once you do everything right, it takes 3 to 6 months. This has been going on typically by the time of diagnosis for 10 to 20 years. So you've got to get there and hang in there. Now, interestingly, his wife called me and she said, look, you're missing the most important thing. And I said, well, what do you mean? She said, well, yeah, he's getting better. This was now at 6 months. And she said, but the most striking thing was he was accelerating in his decline before he started on this, which a lot of people do. They'll go through a period going down slowly and then really take off. And he had done that for 18 months prior to when she brought him to see me. And she said that completely stopped very early on, and then he started to get better. So he talks a little bit here about his story, and you might have to turn down the volume just a little, because he's a little louder than the first person.
And went to open the locker at my gym, and I could not remember the combination, which is, as I know myself, that'd be very unusual. And I would meet with my accountant, say, and we would just toss out some numbers, and I would have the number faster than he could get to his computer usually. So things like that started to wane dramatically. Clearly, I mean, the math has come back. That's a real measurable thing. I mean, I'm fast with math again. People I had met, maybe even taken to lunch, I did not know who they were. I mean, it's like a new encounter. And then afterwards, they'd say, you actually know this person. So that's gone away, which is a relief.
So after he'd been on for 2 years, and it was doing very, very well. In fact, he didn't close the 2 offices. In fact, he opened a 3rd office, and he's doing great. And so I asked him at the end of 2015, would you please go back? We need to document. We need to see where you are. You have great documentation of where you were. Let's find out where you are. And as you might imagine, he did not want to do it. He said, first of all, he said, I know I'm doing better. My wife knows I'm doing better. My coworkers know I'm doing better. He said the neuropsychologist was actually quite negative, quite pessimistic. He said, look, you have Alzheimer's and nobody ever gets better from this. So you've got to get your affairs in order. So we had to convince him finally, look, just go, do the best you can. And so far what we've been seeing is when people know they're better, they really are better, and you check them, they really are better. So you can see here his scores. My wife and I were driving up when he went and got his test. We were actually driving up from UCLA back to the Bay Area. And on the road, my cell phone rang, and we picked it up, and it was the neuropsychologist who said, you have to come see these scores. He said, I've been practicing neuropsychology for 30 years. I've never seen anything like this before. And so here you can see he went from 3rd percentile to 84th on his CVLT Part B. You can see here, for example, auditory delayed memory. He's way up here, gone from 13th percentile to 79th percentile. So he's functioning better than most people here. Having been very poor, he's actually done very much better here. Here, reverse digit span, 24th percentile to 74th, and so forth and so on. So he has done very well. And the most important result we have is that when people improve, and not everybody does, but when people improve, they sustain the improvement. And the first woman I showed you went off and on the program 4 times. And each time she would go off, it would take 7 to 10 days for her to start declining again. She would go back on, she would go back up again. So it's strikingly associated with doing the right things. That is to identify the things that are actually causing it and then to address all of those. So here's another guy. This guy actually called me when I first got to UCLA in mid-2014. He called me. This is a guy who is a brilliant internist. Family history, unfortunately, both of his parents died with dementia. And he has, unfortunately, with his senior moments, he found out he went and did the studies himself, and they were all positive. So he had 1 copy of the ApoE4. He had an amyloid PET scan that was markedly positive. He had a so-called FDG, fluorodeoxyglucose PET scan, which looks at the use of glucose by your brain, and that was markedly positive, typical for Alzheimer's. He had a smaller, shrunken hippocampus, and he had neuropsych testing that showed he was already into MCI. Had not converted, he could still do some things, but he was having a lot of senior moments and really struggling at work. So when we looked at the various factors, his HSCRP, this tells you, do you have ongoing inflammation in your body? Should not be more than 1.0. His was almost 10. Homocysteine, which should be below 7, his was 15, so his was double what it should be. Vitamin D, very important for supporting your neuronal network. Typically should be in the 50 to 80 range. His was 21. I asked him, I was like, you're a doctor, what, you're not looking at this stuff? And he said, you know, these things don't cause Alzheimer's. I said, well, no, each one by itself, no. But this is like asking, what is the one instrument that makes the orchestra? It doesn't work that way. You have to have the whole orchestra. So you've got to have the things that are supporting your neuronal network, and you don't have them. So his testosterone was low, his free T3 was low, his TSH was too high, everything here. So he responded beautifully, and he came in initially and argued with me about everything and kept, you know, I don't believe this, I don't believe that, I don't believe this. So finally I said to the guy, look, give me 6 months. If I can't make you better, go somewhere else. He said, there is no other place. I said, well, okay, then, you know, give me a chance. So after 3 months, his wife came in and she said, wow, he is so much better. And he's still doing, by the way, he's now seeing people on our program and doing very well. So he's another guy, we wanted him to go back and get a follow-up MRI because he had had the shrinkage of the atrophy of his hippocampus. And he didn't want to do it. He said to me, you don't grow new brain. And I said, well, look, you know, people have already shown that exercise alone can lead to small increments in hippocampal size. So let's give it a try. So you can see here, he went from 17th percentile to 75th percentile. And one of the things that's been really striking about these studies is that people don't believe what they haven't been told about before. They think it's impossible. So they're literally faced with something that's blue and they say it can't be blue. So we got a call from the guy who did the MRI and he said, we made a mistake. And then we said, well, what do you mean? He said, well, this can't happen. I said, what do you mean it can't happen? I said, he's doing much better. Why are you so surprised? There have been the studies that I mentioned with the exercise alone. So this guy did a lot more than that and he's doing great. And he said, we've done 75,000 scans at this hospital. We've never seen this before. I said, well, okay, let me get the scans. Let me take them to an independent group, because these are read by computer, the volumetrics. And so we did that. We took them to another group, and it just confirmed exactly what had happened with this guy. And in here, for example, this just shows his gray matter volume, among other things, increased 23%, which is, again, unprecedented. So he's done very, very well. So this is the great sort of thing to get. We've had many, many emails, and this is from a physician. Just wanted to share that my Alzheimer patient had his follow-up visit today and is amazingly better. Family's thrilled with the changes in focus and the ability to carry on a conversation with family members. I just share to thank you so much for your information that is truly restoring hope to families. So we want to see this in millions of people, but any of these things, any email like this is great. So let's talk for a few minutes about what do you do? This is a great time for the students here that are going to go out in the world and change it for the better. So this is a great time to be in neuroscience. I met some neuroscience students this morning. This is an exciting time. There's a lot to do. It's been an area where there's a lot that hasn't been successful for these various diseases, as I mentioned earlier. So how do we go about developing an effective treatment for an incurable disease? And you know, there was a very interesting quote, and I'll paraphrase, from the engineer who was involved with the Ansari X Prize. I don't know if you've ever heard of the X Prize, but it was the original one was given actually for commercial space flight. So you have to send up someone twice in 1 week. So the idea was, could we develop commercial space flight? Let's give a prize for the first group that's actually able to do this. Well, there were specific problems that hadn't been solved. And the engineer pointed out that when you have a problem that a lot of people have looked at by standard methods and it's never worked, you know that the standard methods are not going to work. So anything that anybody comes up with that is going to be that thing that works must be considered crazy. Because if it's not, it would have been something that people knew about. So he said, being successful with this sort of problem means throwing out ideas that everyone else says are crazy. One of them is going to work. Maybe many of the others won't, but you have to understand that what you're going to come up with is going to sound crazy to some people to begin with. That's the only way you're going to solve the problem, which he did, by the way. So we set up the laboratory way back, before most of the people were born, back in 1989. After I trained, we set up the laboratory initially at UCLA. And the whole idea was very straightforward. We wanted to understand neurodegenerative diseases at a fundamental enough level so that we could fashion the first effective treatments. That's the goal. So we wanted to understand, what are these things? So if you take a neuron and you have about 10 to the 11th of these in your brain, you have about 100 billion. So you have a remarkable computer in your brain. Each of these has, on average, almost 10,000 connections, on average. So you have almost 1 quadrillion connections in your remarkable brain. Now, if you break this down and say, okay, well, what does a neuron do? It is basically an integrating analog to digital converter, right? So what it's doing is it's looking at all sorts of inputs. It is integrating over anatomical space, and then it's going to decide, am I going to fire or am I not going to fire? That's all it does, 0 or 1, that's it. So it is converting analog signals that are positive, negative, and all over the map, and different distances from the cell body into yes or no. That's all it does. And so we discovered a set of receptors that we called dependence receptors in the brain, and these things do the analogous process. But what they do is they integrate, instead of integrating over anatomical space, they integrate over chemical space, over biochemical space. So what happens is these things are looking for trophic factors, nerve growth factor, brain-derived neurotrophic factor, hormones, nutrients, things like this. And they're then deciding, do we have enough support to grow and maintain connections, or are we on the red side of the ledger, we're now going to pull out. So there's this beautiful balance that these things create. So we realized over time that, in fact, this is the way these chronic illnesses work. You have a beautiful balance. And in fact, in neurodegeneration, there's a supply and a demand, and you're literally matching these. So if you get osteoporosis, problems with your bones as you get older, it's because these cells on the left here, which are the osteoblasts, they're the ones that are making the bone. They're not keeping up with the osteoclasts, the ones on the right that are turning over the bone. So just like if you're working on your house, imagine that for 20 years you have a contractor who does all the demolition, and you have a contractor who does all the construction. Now imagine that for 20 years, the ones who do the demolition always did extra because they're your friend, and the ones that did the construction never showed up. Your house would start getting smaller and smaller and smaller, and that's exactly what happens with osteoporosis. With cancer, you have the opposite problem because of what are typically somatic mutations. What happens is the signals that are cytoblastic, that are saying, let's make more cells, unfortunately outstrip the turnover of the cells that are the cytoclastic activity. And what we came to realize over time is that the same thing is happening in Alzheimer's disease. You have a whole set of signals, dozens and dozens and dozens of signals, that are synaptoblastic. It has to do with your hormonal levels and your trophic factor levels and your nutrient levels, and whether you've had enough sleep, what your stress level is, what did you eat, is there inflammation ongoing in your body. All these things add together to cause you to have a certain level of synaptoblastic activity and a certain level of synaptoclastic, pulling back from the synapses. And everybody with Alzheimer's has too much synaptoclastic activity for the amount of synaptoblastic activity. Okay, so we want to just map what are all the things that contribute to those. We want to decrease the synaptoclastic activity. We want to increase the synaptoblastic activity. Okay, so how do we do that? What we found is that you can look at these, and let's get the pointer back here. So you can look at these. Here's one synapse, and you can measure biochemically the things that are supporting here and the things that are also pulling back here. And when you're young, you have a nice balance between these two, typically. But as you get older and these things change, you can actually get this one being too long on the bottom here, and this synaptoblastic side being too little. And that's what results in ultimately loss of these synapses. And these synapses actually, they've been likened to interactions, in fact, to relationships, to human relationships, because there's courtship of this element and this element, the presynaptic and postsynaptic element. There's after the courtship, there's commitment, and then there's essentially like a marriage, but these things, they can fight, they have interchanges, they can have positive and negative interactions, and they can ultimately, unfortunately, get a divorce and pull back. So we want to know how to look at these things, and we want to know how to make sure that we keep them on the right side. And the good news is you can now actually focus even more. So we're now going to go even further. We're going to look at one molecule here, which is called amyloid precursor protein. Here's outside the cell. Here's the cell membrane right across the middle here. Here's inside the cell. Here's outside the cell. So this thing is really interesting because it plays a central role in Alzheimer's disease. If you cut this at one place, it makes two pieces that both support the synaptoblastic side. So they're the things that are helping you make and keep memories on this side, SAPP alpha and CTF alpha. On the other hand, you can cut the same molecule at three different sites, which are called beta, gamma, and caspase, and you end up with four pieces that all do just the opposite. They're the things that are telling you pull back. So what happens is you are literally looking at the inputs and saying, okay, just like a CEO would, do I have the interest to do this? Do I have the money to do it? Do I have the permits to do it? Do I have the vision to do it? Do I have the right workers to do it? If everything lines up, then you say, okay, I'm going to add on to my building. So this is a balance that happens. And again, everybody with Alzheimer's is too much on this side. Now, you could argue, okay, let's just develop a drug that prevents you from going down this side. And indeed, that's the way we started. When we realized this balance, we said, okay, let's just get a drug that does this. The problem is, you can actually go, there are other pathways. So you end up still, and of course, you can see, you could end up preventing the body from doing what's physiological, but you wouldn't buy yourself that much. Yes, these things could be very good in combination with all the other things that I show you, and I think that's the future. But the bottom line is we want to go upstream and ask, okay, what actually is causing this? And then the other pieces of Alzheimer's, things like phosphorylation of tau, are downstream from this event. So the big question then was, okay, if you guys believe that in fact this balance is actually important, let's put it to the acid test. Most of the people with Alzheimer's have this ApoE4 that we talked about. Okay, do they have an imbalance? Let's look at that. So we started a project now 10 years ago to look at this, and the idea was simple. Most people, again, ApoE4 here, then they end up with Alzheimer's disease here, and what's in the middle. Nobody really knows what's in the middle. Why is this so important? This ApoE4 is supposed to be the thing that carries around the fat. It's like a fat bucket. So it's a little bit like your butcher. He's the guy who's carrying around fat. Why would that have anything to do with losing your memory? So I call this the chimp that killed the rhino. So this is an amazing gene, ApoE, apolipoprotein E, and as I said, it carries around fat. And if you go back to the simians, so 5 to 7 million years ago, the hominids appeared from the simians. And what happened was, God came down here, touched the simians with DNA, and there's actually a relatively small number of changes between a chimp and a human. In fact, when I told my wife, I said, if you look at all the base pairs together, I said, my DNA is actually more similar to that of a male chimp than it is to yours. And she said, well, duh. So, right? So, I like, Curly and Moe and Larry, and so does the chimp, and I like ESPN, and she doesn't. So, in fact, there aren't that many changes, and one of the important ones is ApoE. So this ApoE4 appeared with the hominids and changed the way this actually functions. So if you look at the structure, quite different structure. You can see here the ApoE4 actually looks like columns here, and ApoE3, which is the one that appeared now just recently, 220,000 years ago. So for 96% of hominid evolution, everybody had 2 copies of ApoE4. Everybody had the very thing that is associated with Alzheimer's disease. And it's only just been in the last 220,000 years that, in fact, ApoE3 appeared. So we suggest everybody should know this, their status. It's always been said in the past, don't find out because there's nothing you can do about it. There's a lot you can do about it, and there's a wonderful website started by a woman named Julie G., who started this website for people. There are now over 3,000 members who are ApoE4 positive, and they share information. It's a social networking site that is wonderful for sharing information that helps people to prevent cognitive decline. So here you can see ApoE4 for all the way 5 to 7 million years ago, ApoE3 just in the last 4% of our evolution, ApoE2 just appeared 80,000 years ago. And so here's, to make a very long story short, here's what we found. In fact, when ApoE4 binds, and it had been known to bind several different receptors, but here's the surprise. It's not just a fat bucket. It also enters the nucleus. It interacts with another molecule called RelA, which is related to inflammation, enters the nucleus, and we found that it actually interacts with 1,700 different promoter regions of genes. So it literally changes the program. So not only is this guy your butcher, he's also your senator. He's changing the laws of the land. And in fact, if you ask, okay, what are the groups of things that it actually binds to? Guess what? You could not write a better story for Alzheimer's disease. So you can see it has to do with inflammatory genes. It has to do with microtubule disassembly, so you're basically pulling back on the neurites. And by the way, if you have this gene, be careful about head trauma because it's harder to get better from head trauma. It's harder to get better from strokes. Here you can see neurotrophins and cell death, aging here, and longevity. So all these things are affected, the very genes you would imagine. So this has to do with Alzheimer's. Okay, so then what we wanted to do is say, all right, in a mouse, we can fix the mouse because when we give the mouse what we call Mouseheimer's, we're giving it a mutation that's associated with Alzheimer's, and then we're just taking that mutation away. So that doesn't tell us a lot. We want to know, how do you get that change in balance that we just talked about? And by the way, the ApoE4s have that balance change, so it fits the model that I suggested very well. So we wanted to know, okay, what are all the things that actually fit, that determine which side you're on? Well, it turns out, as you might guess, in humans, it's a lot more complicated than in mice. But the good news, it's the very things that our epidemiologists have been telling us about. It has to do with your hormone levels. It has to do with whether you've exercised or not. It has to do with whether you have high cortisol or not, and on and on and on. Have you led a sedentary lifestyle? Do you have undiagnosed sleep apnea? These all contribute, and you can literally trace the pathways to see how these things work. So what that means is, if we're going to develop a perfect Alzheimer's drug for humans, here's what it's going to have to do. Okay, So this is the problem. And we've screened for years for Alzheimer's drugs and have one that's now in trial in Australia. But we recognize it's not going to be a cure. We're asking a lot of a single drug. So maybe the idea is you take your drug and you have a backbone program that is personalized and that is comprehensive. So we wrote a computer-based algorithm that tells you, okay, here are the subtypes you have, and here are the things that you actually need to do. So what we tell the patients now is, imagine that you have a roof with 36 holes in it. We're going to have to patch as many of those as possible if we're going to get you over the hump, if we're going to get you to get better. And the idea of patching one hole is not that helpful. We want to do more. The good news is, once you get to a certain number, just as Dr. Dean Ornish found with looking at cardiovascular disease, once you get far enough, things start to reverse. You start to get improvement instead of decline. And that's the same thing he saw with cardiovascular disease. So we got to patch as many of those 36 holes as we can. And what that means is that we need to train a new group of physicians. If you look at the traditional Chinese medicine physicians, they were very good at thinking about the whole body, but they had no idea about microRNAs, or about lipidomes or microbiomes, any of those things. They didn't know any of that. On the other hand, if you look at the 20th century physicians, pretty good. We know about these various microRNAs. We know about lipidomes. But as you saw from the evaluation earlier, we keep thinking that the head and the body are somehow disconnected. We don't think about the entire system the way we should. So we need to develop a new kind of physician who gets both sides, right? Who gets both sides of the story, can use the latest techniques, can use the various computer-based algorithms, but at the same time can also understand, okay, we need to treat this person as a system. We need larger data sets. So I wrote a book about this that came out last August, and for 2 days, it was the #1 book in the world and #1 on Amazon, and we passed Hillary, and we passed Oprah, we passed Tom Brady. 2 days, that's all. And so when we came out, of course, there was some controversy. People said, oh, well, we don't believe this. And some people said, oh, this is just alternative medicine. So what I said to him was, no, this is no alternative medicine, right? There's no alternative. This is the only thing right now that's working. So it's not alternative medicine. The key piece here is about determining what is actually driving you to the wrong side of that balance. If you have cognitive decline, something is driving you, and typically more than one thing. We need to determine all of them, and we need to then address them. And the bottom line here is we're dying of 21st century diseases because we're still practicing 20th century medicine. So how do we prevent and reverse cognitive decline? If you're 45 or over, get a cognoscopy. I talked about this a little bit in the book. It's easy to do. You can get some blood tests. You can get an online cognitive assessment very easily. Blood tests are for inflammation, insulin resistance, hormones, nutrients, toxins, genetics, and the underlying drivers of cognitive decline. Simple online cognitive assessment. You can do this through CNS Vital Signs, Brain HQ, or just do a MoCA test. That's fine too. If you're symptomatic, good idea also to have an MRI with volumetrics. But if you're not symptomatic, you can skip that part. You don't need it. The protocol that we developed, we call ReCODE, for reversal of cognitive decline. So we've mapped all these different contributors, and we go over each one. Is there inflammation? We want to know. If you have systemic inflammation, like the guy I showed you, then you're not going to help yourself until you determine what's actually causing it and get rid of it. We want to get rid of the inducer, not try to trick your system. Do you have insulin resistance? Incredibly common, incredibly important. If you have type 2 diabetes or even pre-diabetes, your risk goes up substantially. Do you have a high homocysteine? Do you have toxin exposure, etc.? You want to optimize each one. Doctors will often say, oh, they're within normal limits. That's not good enough. We want to get you optimized. And a classic example is vitamin B12, for example. And that one, it's normal from 200 to 900, but in fact, at 300. You can die of B12 deficiency while you have a normal B12. So we want to get you optimized, not just to the lower limits of normal. So I always tell people we're now going to treat you like a competitive athlete. So continue to tweak, we want to optimize. And it's a different kind of medicine. We don't want to just give you a pill and send you home. We want to work with you and continue to tweak. And so we now have over 2,000 people on the protocol, over 1,000 doctors from 10 different countries who have trained in this protocol, and we're continuing to train more. So the bottom line here is Alzheimer's should be a rare disease. If we all did the appropriate prevention and early reversal, this would be a rare disease, and that's what it should be. So just to summarize then, what is referred to as Alzheimer's disease is actually a result of a protective response. Your brain is responding to inflammation. Maybe you have undiagnosed Borrelia from Lyme. Maybe you have a tick-borne co-infection, very common problem. Maybe you have exposure to specific molds. People used to think, oh, this couldn't have anything to do with this. It does. It's very, very common. So 3 major metabolic and toxic perturbations, anything that's inflammatory, whether it's infectious or sterile. Trophic withdrawal, if you don't have enough trophic support, brain-derived neurotrophic factor, vitamin D, testosterone, estradiol, progesterone, pregnenolone, thyroid, all these things, you will have that same response. Or also things like specific toxins. And in fact, the amyloid that's in Alzheimer's disease binds very tightly to specific metals like copper, for example. So if you have high exposure to these, your brain is trying to protect itself with this stuff. And so you don't want to just get rid of it, you want to understand what's causing it. There are 3 major subtypes, and these go along with basically, is it inflammatory? That's type 1. Is it atrophic, loss of the support? That's type 2. Or is it toxin? And in many people, it'll be a little from type 1, more or less from type 2, and the same for type 3. So that's why we have now an algorithm that will tell you what percentage of each of these. So you can do that by getting the appropriate tests. So cognitive decline in early Alzheimer's and its forerunners, MCI and SCI, is reversible. These things, the people get better. If they do the right things and they stick with it and they continue to tweak, they typically get better. And most importantly of all, the improvement is sustainable. Once they get better, they don't get worse. They stay. And the people I showed you today are both now 74, actually. And they are, the first woman has been better since 2012 and has sustained that. The second one since end of 2013, and he has sustained that. So that's the most important thing of all. So maybe we want to do a program with the drug. Not surprisingly, the earlier that you get in, the better chance. We have seen a few people who had MoCA scores of 0 still getting better, but that's not as common. We want to look at people, and we want to encourage everyone, get on prevention or early reversal. So the bottom line here is we can and must reduce the global burden of dementia markedly and other chronic illnesses. We're now developing similar protocols, of course, directed toward the things that change in those diseases for other neurodegenerative diseases. And we can increase global cognitive ability, not just treating people who are sick, but treating people who may be off a little, not really recognizing and finding out, hey, I'm actually doing much better now. Through metabolic profiling, larger data sets. We need to know much more about each person. Trying to treat people just knowing their sodium and potassium is not going to help many people. Prevention and early reversal and personalized programmatic approaches to cognitive and overall health. And so medicine is undergoing a major change. We need, in fact, to change the way we think about these things. The future of medicine will be that there will be much more computation in the doctor's office. The doctor can't remember all these very complex algorithms. The doctor, if you hand them your entire genome, they can't simply look at it and say, oh, yeah, here's a SNP here or there. Of course, a computer has to read your genome. And that will be true for all of these complex organisms, or algorithms, sorry. The other thing is that we have to remember that we need to take some of the responsibility on ourselves. In the past, this was a very passive event. You go in because you're sick, and the doctor says, oh, I'm going to make you better. That's old-fashioned. We now, everyone does Google searches. Everyone goes in, and as they say, the patient will see you now. So the patients come in with all these saying, hey, can I ask you about this? Can I ask you about that? So we can get much better outcomes by being more participatory in our own healthcare. So thanks very much again to the Clark Forum, to the Clark family, to everyone from Dickinson, the faculty, and the students. Thank you to Dr. Farrell. Thank you to John. Thank you to everyone for having me, and I'd be happy to answer questions.
We will now begin the question and answer portion of tonight's event. Because this event is being televised, please raise your hand and we'll bring a microphone to you. And as an undergraduate institution, we offer the first few questions to students.
Hi. You mentioned several specific patients who saw a significant reversal of their symptoms after you started them on your course of treatment. Were there patients who did not improve? What was your success rate?
Yeah, so there are patients who haven't improved. In fact, the original paper we published had 9 people who'd improved and 1 person who didn't. And it keyed us in. We then started seeing other patients who were similar to that one who didn't improve. And they're the ones that turned out to have what we ended up calling type 3 Alzheimer's disease, which is toxin related. So now we know much more about that. So things are changing. It's a dynamic process. Here's the bottom line. If you come in early, if you have SCI, pretty much everybody with SCI gets better. If you have MCI, many people get better. And again, you have to do the right thing. I'm talking about people who undergo the testing, determine specifically what it is that's driving the process, and then address those things through the process. If they do that, if they are compliant, if they get on the program, and as I say, typically 3 to 6 months after you get on the program, then many of them will do better. If they have full-blown Alzheimer's disease, where they now have effects on activities of daily living, some of them get better. If you look at, overall, as I mentioned on the slide here, over half of the people who were relatively early on got better. If you go late in the course, then it's the minority. So it depends heavily on what subtype you have, what your compliance is, whether you find the underlying problems, and how far along you are. One of the things we're looking at, by the way, is after you address all these things, now building back, if you've lost significant numbers of cells, you need to build this back up. Are stem cells the way to go? We've just had the first people now going in for stem cell treatments. The idea is we don't want to do the stem cells. It's like you don't want to try to be building a house while it's burning down, right? So the first thing you want to do is put out the fire, identify all the things that are actually causing the problem. Then you now see. Now maybe the stem cells will work much better that way. So we'll see. Questions?
Good evening. I'm wondering how accessible and affordable the program is.
Yeah. So this is, and how simple, that's the third. So the big 3, is it accessible, is it affordable, is it simple? We're trying to make it simple. And unfortunately, the disease is driving how simple this is. When I first talked to a person who was tasked with ridding the world of Alzheimer's disease, and he said, well, if you can get it down to 3 holes, I might be interested. And I said, what are you talking about? We can't argue with the disease. The disease is what it is. Now, having said that, we're doing the best we can to make this simpler and simpler for people. It's getting more and more accessible. We've now trained, as I mentioned, over 1,000 doctors. There are some here, as I understand it, who are very close. Mechanicsburg, is that correct? Right? So that it will be more and more accessible to people. We have a website. You can go on there and actually find someone. They'll have a little map for you. You can see where people are. So it's becoming more and more accessible. Now, the expense, it's not yet reimbursed. Some of the things are reimbursed, but not yet everything. So when cardiovascular disease had its first programs a couple decades ago, it took 16 years for Medicare to finally say, okay, we will support that. So we're hoping that it won't take that long for this. But right now, here's the problem. If you end up paying for a nursing home, you're talking about something between $100,000 a year to $150,000 a year. These are very, very expensive. So we want to keep people out of the nursing homes and not needing nursing homes and being much more independent. So in that case, it's going to be less than 1% of that. But it's still expensive. If you go in and someone says, I'm taking blood from you and it's going to cost you, $900 for blood, that's a lot of money. On the other hand, if the alternative is going to a nursing home in 6 months or a year, then you can see that it's actually a relatively small amount. If you look at what it costs for cancer chemotherapy, for many of these chemotherapeutic agents, it's over $100,000 a year. So this is far less than those sorts of things. But you do need to get the testing. And again, we're trying to make the testing cheaper as well, but it's going to take some time to do that. So yes, that is an issue for people. And another issue is behavioral change. We're asking people to change the way they live. We're asking them to change their diets, to change their exercise, because we're telling them, look, this is what's actually driving you into this cognitive decline. So yes, we look forward to the day when this is, to the day when this is just simple. You go in and, oh yeah, you just do this and this and this. We're very interested in the long run at having an institute where people can come from all over the world and say, look, I really need the full court press on this to do as much as we can. We don't have that yet. So we have many people who are practicing the protocol. Other questions?
Hello, I'm Jordan. Thank you so much for speaking today. I guess I just wanted to make sure I understood the treatment itself, because as we saw from the videos, we saw patients who had great improvement. So is the treatment mostly just improving the health of the patients, balancing the hormone levels, getting enough exercise? I guess I'm just a little bit confused on, the type of treatment that has been working and what worked well for the patients. And I forget if you mentioned this, but if someone went off the treatment, if they did end up declining for a short amount of time. So I guess I'm curious exactly what was working in the treatment itself.
Sure. So as I mentioned, when people have gone off, typically it takes about 10 days or so for people to start noticing decline again. And so we encourage them, get back on. Now, the program is extensive. I wish it were simpler. I hope someday it will be. But the idea is you have to first determine all the things that are driving the process. So, if you have a high hs-CRP because of ongoing inflammation, if you have, P. gingivalis from your mouth that is now in your brain, if you have exposure to Lyme disease or specific molds, if you have mycotoxin exposure, if you have metal exposure, if you have organic pollutant exposure, which so many of us have, all of these things contribute. And one of the common things we see is as people get to menopause, what's happened is they've sequestered many of these toxins in their bones. It's actually a place to protect you. Now what happens, you change your osteoblastic to osteoclastic ratio, you start to release these back into your circulation. So many people at that time suffer some cognitive decline. And interestingly, we see patients, especially with a so-called non-amnestic Alzheimer's disease. The classic one is, of course, the main problem is forming new memories. But in these people, they have trouble with organizing, so-called executive dysfunction, or problems with calculating, or word finding, or recognizing objects, things like that. So for the program itself, I go into this extensively in the book, but basically it has to do with addressing those things. You may need specific antibiotics for specific infections that are causing the inflammation. And then we start simply. Their diet, you have to be on the kind of diet that has an anti-Alzheimer's effect, which means we call this KetoFlex 12-3. So we want to drive people into mild ketosis. It's a plant-based, whole foods sort of diet, very low on carbohydrates. You need to heal your gut. You need to make sure that your gut is not leaking, and so many of us are. You need to make sure that you don't have sleep apnea. That contributes to this problem. So exercise turns out to be another piece. What happens when you exercise? You actually make more brain-derived neurotrophic factor in your brain. There are now, the good news, there are other ways to do that as well. Sleep, you want to know whether you have sleep apnea. Stress, you want to keep your stress levels low. Cortisol is not good for your hippocampus, not good for your brain. High levels of cortisol, especially sustained. Brain training turns out to be very important. And people have said, oh, brain training is not helpful. Well, if you're doing it without all the other things, it may not be so helpful. But in fact, as an overall part of the program, it can be very helpful. And then there's a whole set of things. And as a scientist, if you had told me 10 years ago that I was going to be telling people that they needed to take specific herbs and specific targeted supplements, and that they need to find joy in their life, and they needed to have, see if they have sleep apnea, I would have laughed. I would have laughed at this 10 years ago. But I can't argue with the data. These things actually help, and you're actually now getting at the factors that are actually causing you to have the problem. And this doesn't stop you from using drugs as well. It just says you need to have the rest of this as well. Some people need to have what's called bioidentical hormone replacement therapy, so you want to optimize those things. Some people we find, as I mentioned, the guy whose vitamin D was very low, these things are all part of driving. So you're now treating a system instead of just treating with a single drug. Yeah, people always ask, what's the most important thing? The most important, is there a common factor? The most important thing here is actually to get the testing so that you can see what's driving the problem. If you look at this overall, probably the most common thing is that people have been exposed to specific biotoxins. That seems to be a very common thing. But there are some people who have no problem with that at all. So again, this tells you this is not about one thing that causes this problem. It is about a network, and you have changed the performance of a specific network. It's just like saying, if your computer breaks down, let's look for all the things that could have caused that. And it's the same thing here. You have a network that is now changed in its activity and ferreting out those things that changed it. And the good news is we know about a finite number of things now that tends to do this. Okay, other questions?
We have time for a couple more questions at this time.
Hi, so you mentioned before this kind of all took off, you applied for you wanted to do a trial, and I think you said Australia, and were rejected because you were changing more than one thing.
Right.
And my question is, since then, clearly the ReCODE protocol has taken off. It's been worked with, or at least working with thousands of people. What kind of testing have you done since then to back that up?
So we're now proposing another clinical trial that will be done in the United States instead of in Australia, and we're in stages where we've got to get the IRBs to sign on. And remember, we're changing a lot of rules here, so we're asking the IRBs now to say, okay, even though this is not a monotherapy, you're not just changing one thing, you're changing one network, the performance, and we have to get some buy-in on that. So we've had discussions with the IRB that is supportive of this idea. And so, yeah, now we have papers published that we didn't have with the original one. So our hope is that we will get approval to do this. But yeah, that's exactly the point. Meanwhile, we want to continue to refine it and look at, for the people who are not doing well, why is that? What is being missed in the people who are doing poorly versus the people that are doing well? What is the difference?
For a final question, we have a question that came in from the live stream. So this is from Rob Weichtman. He asks, I've seen a study that suggests that APOE4 positive people do not positively respond as much to omega-3 supplementation as APOE4 negative people. Any thoughts for possible reasons?
So there are all sorts of different thoughts about lipids and APOE4. And again, this is discussed nicely on the website I mentioned. What we do know is that people who actually are eating a high-fat diet, and mostly polyunsaturates and monounsaturates, despite this high-fat diet, and we encourage people to, of course, include fiber. That turns out to be very important, both on the toxin side and on the microbiome side. they do very, very well. We encourage people to check their LDL particle numbers or their so-called small dense LDLs or oxidized LDL. Any of those three, fine. Your total cholesterol is not so important. That's not the bad actor. It's the oxidized LDL that actually gets you into problems. So specifically with respect to specifically with respect to omega-3s, we still encourage people to use those. And people who use those who are ApoE4 still tend to do well. Do they do as well? Yeah, there are many differences between the ApoE4 positives and negatives. But in fact, overall, on the program as a whole, the ApoE4 individuals tend to respond a little easier, a little better to the program overall, although both can respond to it.
This concludes tonight's event. Please join me in thanking Dr. Dale Bredesen.
Thanks.